Lesson 110, converting repeating decimals to fractions. So first here you can see some steps in turning decimals, repeating decimals to fractions. You need to write a couple equations. The first equation, let x repeating the decimal. So here my equation x equaling 0.77 or 0.7 repeating. And then let n, the second one, or let n, whatever n is, the number of repeating digits. So in this example, there's one repeating digit. So you're going to multiply that by a power of 10. So here you see 10 to the nth power. Since it's one repeating decimal, 10 to the first power is just 10. So you write your second equation, power of 10 times x equaling your 7.777 repeating. So you just multiply that by 10. So I have 10x equals 7.777. The next step is to subtract the first equation. So this x equals 0.777 from 10x equals 7.777. And when you do that, you end up with 9x equaling 7. Solve for x by dividing by 9. There's your fraction. You can always double check that because if you did 7 divided by 9, you would get 0.7 repeating. So let's review those steps once again. To write the first equation, choose a variable. You can always use x and make it equal to a decimal. So let's just say I chose the letter x equaling the repeating decimal. Let's just say it was 0.22. So the 2 is repeating. Next it says to make the second equation, count the number of digits that repeats. So in this case, let me make this 0.27. So I'm repeating the 227, so 2 digits. So that's 10 to the second, which is equal to 100. And then multiply both sides of this equation by 100. So that would be 100x equaling 27 point, and it's just going to continue 2727. And then to make the third equation, subtract the first equation, which is up here, from the second one. We're going to have 100x equaling 27.27. We're going to subtract 1x equaling 0.27. When you do that, you end up with 99x equaling 27. And then you divide by 99 on both sides. So you have 27 over 99, which I can divide this by 9/9, which will give us 3/11. And there's our fraction. So let's take a look at an example here. We got convert 0.16 to a fraction. And so our first equation is choose a variable. We'll choose x equaling our repeating decimal. So 0.16 with the line over the 6. Second step, count how many digits are repeated. There's 1. So I have to multiply this whole thing by 10. So 10 times x, and then 0.16 repeating times 10 would give us 1.6. And I'll just do another 6 because 6 is repeating. Our third step, subtract the 2. So now I just subtract this part with here. So I'm going to put minus 1x equaling 0.16. And all these other ones, these would all be 6s. So this is 0, 0, 0. 6 minus 1 is 5. 1 minus 0 is 1 equals 9x. So really I have 9x equaling 1.5. So I take my my 9 and divide that by 1.5, so or take my 1.5 and divide that by 9. So 1.5 divided by 9 equals, actually I gotta keep it as a fraction, So I can't have decimal in my fraction, so I have to get rid of my decimal. To get rid of the 1.5, I need to multiply that by 10. Whatever I do in the numerator, I do in the denominator. So multiply that by 10 tenths, which would be 15 90ths. Then I can simplify. I can divide 15 90ths by 15 over 15. 15 divided by 15 is 1. 90 divided by 15 would give us 6. So our answer would be 1/6. Next, the theoretical probability of rolling a 12 with 2 number cubes is 0.027. About how many times would you expect to roll 12 in 180 rolls? So choose our variable, make it equal to the repeating decimal, so 0.027 with only the 7 repeating. We need to now multiply that by however many digits is repeating. There's just 1, so multiply everything by 10. So this would be 10x equaling 0. Move this one place, 2, 7. The 7 repeating. Then I'm going to take this part and subtract it from here. So now I have minus 1x equaling 0.027. 7's repeating here, so I put that 7 there. Subtract, and I get 0.25 equaling 9x. To get x by itself, I divide by 9. But I can't have decimals in my fraction, so I'm going to multiply this by 100 to get rid of my decimal. Multiply the bottom by 900, so I have 25 over 900. And I can simplify that by dividing the numerator and denominator by 25. This would be 1, and 900 divided by 25 gives us 36. So 1/36 for one time, but you're doing that 180 times. So if I take my 136, or 1 over 36 times 180, so really it's 180 divided by 36. That would give us an answer of 5. So you can expect that to happen 5 times. Next, convert 0.8 to a reduced fraction. So I choose a variable, make it equal to my repeating decimal, so 0.8 repeating. Since I have 1 repeating decimal, I multiply at both sides by 10, so this would be 10x equaling 8.8 repeating. Then I take my top equation and subtract it from the second equation, and I get 9x equaling 8. Divide by 9 on both sides, x would equal 8/9, and that's what 0.8 repeating would be. Next one, convert 0.72 to a reduced fraction. So x equaling 0.72 with the 72 repeating. My next one, since I have 2 digits repeating, I multiply it by 100 on both sides. So 100x equaling 72.72. Because the 72 is repeating. Take the top equation, subtract it from the second equation, so minus 1x equaling 0.72. And now I have 99x equaling 72. Divided by 99. I can divide this by 9/9. This would give us 8 over 11. A couple other ones, 0.83 with the 3 repeating. So a variable equals 0.83 with the bar over the 3. Second one, since I have 1 decimal that's repeating, I multiply by 10, so 10x equaling 8.3 repeating. Subtract the top one, so minus 1x equaling 0.83. Remember, this is a 3 as well because the 3 is repeating. That gives us 9x equaling 8 point, not 8 point, need to borrow, it's supposed to be 7.5. Divide this by 9. Then multiply this by 10 tenths, so I get rid of my decimal, and I have 75 over 90. I can divide this by, 15 fifteenths. 75 divided by 5 is 15, or 75 divided by 15 is 5. 90 divided by 15 is 6, so our answer would be 5/6. The next one says write 33.3 repeating percent as a repeating decimal and then as a reduced fraction. So remember, as a percent, we would have to divide that by 100. It just means move it 3 places to the left. And so we would have 0.3, and the 3 is repeating, so it'd just be 0.3 repeating. So that is our reduced, our decimal. Now to change that to a fraction, choose my variable, make it equal to the percent, the repeating decimal. 1 digit is repeating, so I multiply this by 10, so 10x equaling 3.3. Take this top one, subtract it from the bottom one, so minus 1x equaling 0.3. And I get 9x equaling 3. Divide this by 9. Divide numerator and denominator by 3/3, and you get 1/3. And 1 divided by 3 is 33.3%. And our last slide, write 12.12% as a repeating decimal. So again, just like that last one, 12.12 divided by 100, 12. That gives us 0.12 with the 12 repeating. Now change that to a fraction. So x equaling our repeating decimal, so 0.12 repeating. 2 digits are repeating, so multiply that by 100. So 100x equaling 12.12. Subtract this equation from the second one, so minus 1x equaling 0.12. We get 99x equaling 12. Divide by 99. I can divide this by 3/3, and I get 4 over 33. And our last one, the theoretical probability of rolling an 8 with a pair of number cubes is 0.138 with the 8 repeating. So that's my first equation, x equaling 0.138 with the bar over the 8. How many times would you expect to roll 8 in 180 rolls? So this one is like the previous one that we've done with 12, rolling in 12 for 180. So we need to convert this to a fraction. So 1 digit is repeating, so 10x equaling 1.38. Subtract this top equation with the bottom one, so minus 1x equaling 0.138. So remember, the 8 is repeating here. Subtract it, you get 9x equaling, this would be a 5, this is a 2, 1.25, divide by 9. To get rid of my fraction or decimal, I need to multiply this by 100. So this would be 125 over 900. I can divide this by 5/5. 125 divided by 5 gives us 25. 900 divided by 5 gives us 180. I can divide this by 5 again. So 180 divided by 5 gives us 36. So 5 out of 36. So now if I take my 5 over 36 times 180, 180 divided by 36 is 5. So if I divide 36, I'm left with 5 times 5, which is 25. So it happened 25 times to get 8. So that's our lesson today on converting repeating decimals to fractions.